Welcome everyone. In this video lecture, we will solve a GATE 2019 question in which we have to find the range of input voltage to turn on the Zener diode. Okay, or we can say the range of the input voltage through which the Zener diode will be turned on. Okay, so in this question, it is given a Zener diode is given, and for that particular Zener diode, the Zener diode maximum voltage or Zener diode that will work for a 20-volt Zener. Okay, and the maximum current through that Zener will pass is 60 milliampere. These two are given, and the value of R1 is given 200 ohm, and the RL value is given 1 kilo ohm. Okay, so we have to find the range of VI, and this one is the circuit. We have to find the range of the VI to which it will maintain the Zener diode in the on state. So this one is the thing. Okay, so we can consider the first thing, during what time the Zener will operate. So I'm just going to draw a Zener, okay, in which this one is our VZ, and some current will flow from cathode to anode. Okay, and as we know, the diode characteristics. Okay, okay. Zener diode is nothing but simply we can say we have to make a diode which will work in the breakdown region. Okay, so this point is called our minus VJ. Okay, and this one is say minus IZ min. So in Zener diode we have to keep the voltage VZ constant, that is our 20 volt, but the IZ value will change. Will change. Here we can say the IZ value will change either from IZ min to some other value like I max. Okay, it may be any current. So in our case, it is given the maximum current that will flow will be 60 milliampere. So the minimum current may be considered at zero milliampere, because if some Zener is there, one can say the Zener will be like this. Okay, means it should be minus Vz, so it is almost at zero. Okay, this should be our I. Okay, Iz and V, or simple diode one also can say I and V. So the maximum value of that Iz is given 60 milliampere, and so minimum Iz min will be 0 milliampere. Okay, so this one is the concept. So the thing is that we have to first know what is the minimum value across the diode. So when we are considering, so there may be two possibility. Say case 1. Why I am writing case 1? In which we are just assuming that Vz equals to V equals to 20 volt, or say this VL, this is a plus of minus VL. Okay, and this one is our plus minus Vz. Okay, and in this time we are saying there is almost zero current is flowing through the circuit. Okay, so almost zero current. So I am just making the same diagram here. So what we observe that for in this case, what we are saying, the current across the Zener is 0 milliampere minimum, but the voltage will be same, 20 volt. 20 volt. So this value will be 20 volt. So all current will flow from this one IL. Say IL. Okay, IL. So now this IL value will be simply our VL by RL, that will give 20 by RL value is given 1 kilo ohm. So it should be our 20 milliampere. So in this case 20 milliampere current is flowing. This one is our 20 milliampere current. Okay, and this one will be 0. Okay, so after that what we have to find this Vi. Okay, so if we apply Kirchhoff's voltage law, okay, in this loop, okay, so what we can write KVL in loop 1. Okay, so one can write Vi minus R1 IL minus RL IL equals to 0, or this value is VL, so we can also write Vi minus R1 IL minus VL equals to 0. Both are same. So Vi can be written as VL plus R1 IL. So VL is same as that of Zener voltage. It should be 20 volt plus R1 value is 200. R1 value is given 200 ohm, and IL we have already calculated 20 milliampere. Okay, so it should be 20 plus 2000 means 4, then it should be 4, so 24 volt. So in this case the Vi value will be 24 volt. Okay, Vi value will be 24 volt in this case when we are considering the zero minimum current in the crossing through the diode. Okay, so now the next condition what we can do, it is our case 2. Vz will be same. Okay, because we general have to on, and now the maximum current through the general will be given 60 milliampere. This one is the case. Okay, so again what we are doing, we are just putting the same diagram here. Okay, so in this case what is given, the maximum current through this one is Vz, and maximum current is given 60 milliampere. Okay, so we can say this one is 60 milliampere and this should be 20 milliampere, because we have to maintain this one VL constant voltage. This one because general acts as a regulator. Okay, so this we have to make it constant, so it should be 20 milliampere. So the overall current will go through this one will be 80 milliampere. Okay, so now again if we go for the Kirchhoff's voltage law in this section, say again loop 1, so one can write Vi minus R1 into 80 milliampere minus, it should be VL, that is our 20. So simply 20 volt we can write equals to 0. So Vi can be written as 20 plus R1 into 80 milliampere. Okay, so just try to put R1 value will be 200 into 80 into 10 to the power minus 3, so 16. So 20 plus 16, 36 voltage, 36 volt. So in this case the Vi value will be 36 volt, that will give the maximum current across the 60 milliampere will be general will be 60 milliampere. So Vi value will be 60 volt when we are considering a maximum current is flowing, that is our 60 milliampere across the general, and the Vz will be same because we have to make this as a constant voltage across the load. So it should be 20 milliampere and VL will be 20 volt. So the range will be Vi will be here simply our 36. Vi will be 36 volt. So the range will be 24 volt to 36 volt will be the range So the option will be 24 to 36. That is our option number 2. So this one is a simple question, but we have to very careful about the concept that the minimum current, when the diode is on, the minimum will be IZ mean. But for the ideal purpose, we are saying it should be 0. Then we have to calculate the V1 value, then IZ max, then we have calculated the VI value. So R1, RL is given, and this voltage will be always 20 volt. This value will be always 20 volt because the Zener diode will operate in the on condition, so it should be always 20 volt. Okay, because the overall voltage across the load will be constant, even the supply changes and the this current will change. Okay, this is all about this question. So thank you for watching this video.